Welcome to you, friends of the SETI Institute. We are here in Laguna Lejia in the Chilean Altiplano, where our team is finishing a almost 4-week leg of the biosignature detection project. My name is Nathalie Cabrol. I am the director of the Carl Sagan Center for Research at the SETI Institute. We are here today as part of a project funded by the NASA Astrobiology Institute that seeks to understand how to detect biosignatures. The conditions that we are experiencing right now in the Altiplano are not exactly easy. We have been under a windstorm for the past 2 days. The story of Laguna Lejia is very similar to what we witnessed on Mars, is the association of a lake history and volcanism. So in the terraces of Laguna Lejia, we are sort of witnessing what could have happened on Mars. And by studying those layers, we are learning maybe how to recognize them on Mars, but also maybe how to be able to extract biosignatures that may be contained in those layers. So here we are in front of one of the outcrops of Laguna Lejia. And you have the story of two very different lakes. The first one is exposed here and is the most recent part of the lake, where you see a succession of ash deposits and salt deposits. Very thin layers, very bright, light tone deposits. This is very different. When I started seeing this layer appear, it was like walking into time. It was just stepping way back, like 10,000 years ago. Now you can see the different layers, and they are repeating themselves. A change in color, sometimes there is a little bit more of a dark color, sometimes a little bit more of an orange. The dark and orange are associated with organic matter. The different colors are associated with the composition of the sediment depending on the season. So the valves are definitely associated with glacial deposit. This is Laguna Lejia over 10,000 years ago. And from time to time, you see layers like those that are including worm tubes. All you see here are worm tubes encased into more textured sediment. Obviously, we're not expecting to see worm tubes on Mars. The organism we're expecting to find, if any, will be a lot more primitive. Cyanobacteria, blue and green algae, developed very early on Earth. And about 3.8 billion years ago, they provided the first fossil evidence of life on Earth. So the adaptation of the microorganisms that are here can tell us something very profound about the potential for adaptation of microorganisms on Mars, the type of pigment we should be looking for. So basically, these are the elements that we are looking for to try to understand what kind of biosignature we are looking for, what kind of scale, and what type of resolution we should be searching for. This project is under the umbrella of the Astrobiology Research Division of the SETI Institute, and really fits under our mission at the Institute, which is to understand the nature of life and its distribution and the future of life in the universe, and simply to understand if we are alone in the universe. In ways to say goodbye and thank you for sharing this time with us, I am going to follow what has become a tradition, which is to sort of deploy the SETI Institute expedition flag number 1, which I always have with me in expedition. I'm going to just put this on the floor. Flag number 1 has come to the Andes a few times now. Flag number 2 is a few kilometers to the south with Dale Anderson in Antarctica. And flag number 3 flew with Pamela Harmon and Bill Diamond about 1 week before we left, which is now 3 weeks ago, and flew with teachers on the Sofia Airborne Observatory. So thank you very much for spending this time with us. Please keep supporting the SETI Institute. Visit online, and if you can, visit us at our headquarters in Mountain View. Thank you very much again. Goodbye.